Okay, you should be on page 1 of your packet. This packet is going to be the first grade on the 4th 9 weeks and will also be your last test of, before spring break. The packet is all about probability, and probability is a fraction where you have your total outcomes on the bottom and your possible outcomes on top. This first example though, since they are already given us the numbers in percentages, we do not have to write out a fraction. I can instead just use these numbers. So the question says, find the probability that a randomly chosen team member runs only long distance or competes only in field events. The word or is important because that means you're going to be adding two probabilities together. So the first says runs only long distance. 8% run only long distance, so that's going to be 0.08. So I need to change it to a decimal. And then competes only in field events. 32% compete only in field events, or 0.32. So I'm adding those two probabilities together, and that gives me 0.4 or 40%, which is our answer. So again, because they were given to me in percentages, I don't have to write it out as a fraction, and the word or means you add two probabilities together. All right, let's try the next one. The table shows the results of a class survey. Find the conditional probability that a student did more than 2 hours of homework last night, given that the student is a female. Okay, so this one I'm gonna have to write out as a fraction. What follows the word given goes on the bottom of your fraction. It's your total. So given that the student is a female, if I look at this chart, I have to find the total number of females. Here's my female column. The total would be 10 plus 8, which is 18. So 18 should go on the bottom. And then, since this is my total, I'm only looking at this column to figure out what number goes on top. So it's either gonna be 10 or 8. So if I go back to the problem, it says, given that they're female, but there's 18 females, how many did more than 2 hours of homework? 10 females answered yes, they did more than 2 hours of homework. So it's gonna be 10 over 18. You don't have to change that to a percent unless you want to, but you can leave your answer like that and that will be fine. All right, page 2. There's a chart down here. I don't know why it got cut off, and the only thing that says is like popcorn. So we have to actually take a few minutes and fill in this chart before we can go answer the question. All right, give me a second. Have to go off of memory here. All right, this is gonna be likes candy. So you might take some time, maybe pause the video and get this chart created so that you have it. Doesn't like popcorn. Total, okay. That goes there. That goes there. I think that's the numbers we have. We'll say this. Okay. Okay, so make sure, again, pause the video if you need to. You need to fill out this chart just the way I have it here before we'll go up and read the question and answer it. Okay. So hopefully you have the chart created. So if I go back up to the top, Rosa collects data on what students at her school like to eat at the movie theater. She randomly asks 120 students 2 questions. So that's why in our total box down here, our complete total number of students she asked was 120. She asked them, do you like to eat popcorn at the movie theater? Do you like to eat candy at the movie theater? Her data is partially shown in the table. Of the students she asks, 60% of those who like to eat popcorn also like to eat candy. Complete the table to show the number of students in each category. Okay, so this is important where it says, of the students she asks, 60% of those who like to eat popcorn also like to eat candy. you gotta be careful when you read this because it's saying 60% of those who like to eat popcorn, not 60% of the total, 60% of those who like to eat popcorn. If I go down to my chart, if I look at like popcorn, that's a column, the total that like to eat popcorn is 70. So I gotta take 60% of 70 to see which, how many students also like to eat candy. So to review that, if you're gonna take a percent of something, you have to multiply. So 0.60 times 70, which is gonna give you 42. So 42 students like to eat popcorn and candy at the movie theater. So that's gonna go here. Now, I can go ahead and fill out the rest of my chart because these two numbers have to add to my total, which is 70. So if I'm missing this box, I can do 70 minus 42, which is 28. The total also has to add up this way. So the totals have to add up in terms of columns and they have to add up in terms of rows. So here I could do 120 minus 70 to figure out what goes in this box here, which would be 50. To find the total here, I can add 28 plus 34, which will give me 62. Now, I'm missing both of these boxes. However, I can get this one again because these two numbers should add to 120. So again, the column should add up to the total and the rows should add up. So I can do 120 minus 62, which is 58. Now I can go ahead and get my last row. 58 minus 42 gives me 16, which goes in that box there. So now my chart is complete. All right, so again, pause the video if you need to finish filling this out, but I'm gonna move on to page 3. We have 2 more questions to do. This first one, we're just filling in where these numbers go in the correct box. So a survey of 200 downtown workers revealed that 31 females ride the train. Okay, so I need to put in the female, ride the train, there's 31. 24 females ride the bus. Okay, that would go there. 44 males ride the train. Okay, that's gonna go there. Oh, I skipped the part where it said 35 females carpool, so that should go here. Okay, back to right here. 38 males ride the bus, that should go there, and 28 males carpool. So that question's done. All I had to do is put the numbers in the correct box for the chart below. But again, keep in mind that technically here, we have totals because all the columns should add up to a total and all the rows should add up to a total. But we don't have to do that in this case. It just needed us to fill it in. Okay, last question. The probability that Alexis will make a free throw is 0.3. The probability that she will make 2 consecutive free throws is, so, down here, if I go a little further, let's see, I see the word and, like on page 1, if we saw the word or, that means we add the probabilities together. If we see the word and, we're multiplying. Even though this first question doesn't have the word and in it, we're still gonna multiply because it's 2 independent events, meaning the probability of her making the first free throw does not affect her probability in making a second one. So since it's 0.3 to make 1 free throw, I'm gonna times that by 0.3 again for the second time that she tries. Multiply that together, you get 0.9, oh, I'm sorry, 0.09. There we go. So there's your answer for the first one. The next question says the probability that she will make the first and the second and not the second with doing 2 free throws. So she makes the first, but she does not make the second. Again, the word and means we're gonna be multiplying. So the probability that she makes one is 0.3 times, okay, what would be the probability that she does not make it? I don't want to say 0.3 again because this time she doesn't. Now, probability is out of 100. So if 30% of the time she's making it, that would mean 70% of the time she does not make it. So I'm going to multiply this by 0.7 and you multiply that together, you get 0.21. So there's a probability that she makes the first one, but not the second. And the last line, the probability that she will make neither would be, okay, so we have a 70% chance of her not making it. So that's gonna be 0.7 times 0.7, because it happens 2 times in a row, which would be 0.49. All right, so that's where we're gonna stop today. Ignore the bell ringing behind me. Let me know if you have any questions, and then you should complete the exit ticket and get that turned in.